Why are all of these answer choices wrong? I mean.
Because that was a repeating.
Right, so you're saying that this is repeating. So what's different about all of these numbers compared to what this actual value is? What's the difference between that? Esteban?
Because none of them have repeating symbols.
So none of them have repeating symbols, and I'm hearing that. I want to think about the values of the two things. So if I had written this with repeating, what is the difference between the value of this and the value of this? Marquita. Yeah, so she's saying that this stops, which means that if we give this answer, that means that we're pretending like none of this exists. Is that okay? Well, it depends on what you're talking about. If you're talking about something that you're doing in science, that may make a big difference. Things that happen out there in those decimal places may make a huge difference. Okay? So the difference between these answers is that one of them is an exact answer and one of them is an estimate or rounded answer. Now, let's talk about some rounding here for a second. Most of you did round, decided you wanted to round. You chose answer choice C. Thinking about rounding, if you wanted to round to the thousandths place, and we've seen this on our homework plenty, you would have circled the thousandths place. You would have looked at the number next to it and determined whether it needed to round up or down. You would have seen a 6, and you would have rounded up. If you had rounded correctly, show me with your fingers which would be the correct answer. Answer choice D. Of the choices you were given, answer choice D was the most correct answer. However, most of you gave me answer choice C because somewhere along the line, somebody let you be bad rounders. Shh. I'm not going to blame anybody. Perhaps some of you have yourselves to blame. I don't know. Reality of it is that you need to realize the reality of it is that most of you have gotten to the point where when you end up getting an inexact answer and you want to round it, you just use whatever the last number is that you divided out. When the reality is that if you want to stop doing division and you want to round, you have to go one decimal place further and use that to round. So, if we want to round to the hundredths place, like somebody might have done on this one, we would stop at 0.416. We could circle the 1. We'd have the 6 to look at. It would round up to 0.42. So, from here on out, if you want to round something, and I'm going to tell you 9 times out of 10 to round to the thousandths place, that means you have to go one decimal place further to round correctly. Questions about that? Denzel.
So if it's 0.41777 feet, then we round it up to be 0.418.
Yes. So, today, however, we will not be doing any rounding. We'll be talking about repeating decimals or terminating decimals. And so in order to determine if something repeats or terminates, you'll have to just keep going until it either repeats or terminates. This is something that I think a lot of you have a lot of background with, repeating and terminating decimals, so hopefully we'll keep this brief. So I just want to engage ourselves in thinking about the word terminating by thinking about the Terminator. Raise your hand if you are familiar with the movie The Terminator. Shame on you guys, it's rated R. But since you have so much background, since you guys have so much background with the Terminator, that allows me to continue to use this. Now, why would they call Arnold Schwarzenegger's character the Terminator? What is it that he did that makes him a Terminator? Why do they call Arnold Schwarzenegger's character the Terminator?
They call Arnold Schwarzenegger the Terminator because he would blunt and then he was a robot and he would go around and kill the lady that shakes shit and made it on.
So what I'm hearing you say is that he killed lots of, I think, robots, aliens, robots. He killed things. Which means that, in reality, he ended those things. He stopped them from being. So, when we think about the word terminate, we're talking about something that ends things, which is why when we talk about decimals that are terminating decimals, those are decimals that end. This all makes sense. So, what we're going to do is, I think all of us have in our brains what terminating and repeating decimals are. I do want you to go ahead and do this work independently. I want you to convert each of these fractions to decimals. And there's an and there. There's an and, so I want to make sure that you're paying attention. And go ahead and answer this question. Okay, do that on your own. We'll check back in a second. What did we get for the first decimal? Marquita. Anybody get anything different? Christy. I know. So, what do we get for the second one? Nehemiah. Is this what you said? It's okay. Let's see, what's wrong with this?
The decimal is not at the right place.
I'm concerned that we didn't all hear that. Maybe it's because the windows are open. Itzy, why is this incorrect?
Because it's in the decimal is in the wrong place.
So Nehemiah, what's wrong with your answer? Hint, he just said it. Yeah, decimal error. So remember that the decimal should always pop straight up. So when we had 7 and 8, the decimal is here, it pops straight up. You have to get to 70 before it can go in 8 times. Okay? What's the difference? RJ. You're going to have to say that a lot louder for everybody in the room to hear.
One's repeating and one's not.
Okay, so one is repeating and one is not. Now, here's what I'm going to tell you about all fractions. All fractions either repeat or terminate. That property of repeating or terminating also puts them in a category called rational numbers, which we're actually going to talk about in a few days. We're also going to talk about irrational numbers. Now, that being said, we know that all fractions are either going to repeat or terminate. So all fractions in rational numbers either repeat or terminate. That means that when we're talking about a fraction and we want to change it to a decimal, there is no point in time when you are ever going to run into a fraction that doesn't either repeat or terminate. You may have to go out to 3, 4, 5, 6, 7 or more decimal places to figure out where it repeats or where it terminates, but it will eventually. So there are some numbers that have a pattern of 9 different digits or more for their repeating pattern. We're not going to run into any of those today. I'm not going to make you do any of those today. But it happens. All fractions will either repeat or terminate. So if at any point in time in your work today, you feel like you've gone far enough and you haven't found a repeating pattern or it hasn't stopped, the response is either you have a mistake in your division or you need to keep going. So all fractions either repeat or terminate. And what that means for us today is that there's no such thing as stopping. We'll eventually find a repetition or a termination. Yes, Cassandra?
Okay, so you're in a problem and you have 4, 5, 6, and you show 4, 5, 6, 4, 5, 6. Is that still repeating?
That is still repeating. So Cassandra is bringing up the instance or the case, and I'm really glad she is. She's saying, if we got something and we were doing the work and we got 4, 5, 6, 4, 5, 6, 4, 5, 6, blah, 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 and it goes on and on and on, would that be a repeating decimal? See most of you showing me Kip. Yes, absolutely. And the way we would write that in decimal notation is we would take that pattern that's repeating, which is this 4, 5, 6, and we would put our repetition bar over the entire thing. Okay? Monia. So she's talking about whether we should put it on the first one or the last one. So it doesn't matter actually which one we put it on, because you'll notice I put my repetition of this 0.83 way, way, way out here. It doesn't really matter which one you do. You could do the second one. Or, interestingly enough, if I pay no attention to this first letter, if I were to say, hey, let's pretend like that 4 isn't there for a second, the pattern now looks like 5, 6, 4. I could put my repeating over the 564. As long as you have a pattern that repeats over and over again, it doesn't matter where you start. Trayana.
So what if it's like, it keeps going through the pattern?
We will not run into anything like that today because we are dealing with only fractions. And all fractions will repeat or terminate eventually. All right. So, looking at this one, we've already done this one. Just checking in on our repeating notation. Remember, the notation goes only over what's repeating. And on this one, if we do 20 divided by 3, we get 6.6 repeating. The point that I really want to make with this 20 divided by 3 is that you cannot put the repeating notation over a whole number. So some of you may want to go like this. Oh, I see that this is repeating from here. You cannot put the repeating bar over a whole number. The repeating bar always has to go over only decimal place values. Cassandra.
So no matter if you, like, for example, if you get 4.4, and then you cannot put it over, like, all of them.
Yep, so Cassandra's asking something about like this, just for clarification. The only place I can put the repetition is somewhere on this side of the decimal place. Any other questions or clarifications? Matthew and then Marquita.
Do you recommend us like what place to stop at? Like what place to stop at?
So today, because you're looking for the repeating or terminating decimals, you won't stop until you figure out whether it terminates or repeats. In the future, I will probably have you stop and round at the thousandth place. But that's in the future. Marquita. Okay, cool.